Hello, everyone. My name is Dan Jonas Roach, and I am the news editor here at the Architects newspaper. I'd like to welcome you all to the Sustainable and Circular Materials Understanding Aluminum Recycling live webinar, a CE Strong webinar series powered by the Architects newspaper. This webinar is sponsored by Hydro. This program is registered with the AIA CES for continuing professional education. Questions related to specific materials, methods, and services will be addressed at the conclusion of this presentation. This webinar is recorded and can be easily replayed when re-registered on the same webinar registration page. Please allow 7 business days to process certificate of participation and AIA credit reporting for this presentation. Now, I'd like to introduce you to today's presenters, Hilda Kalevig and Helen Waykamp. Hilda has a decade of experience in the aluminum industry where she has worked extensively with architects and designers to explore the creative and sustainable potential of aluminum. As former head of global brand at Hydro, she led strategic brand initiatives across 40 markets, including the launch of Hydro's greener brands. Hilda has spearheaded collaborative projects with renowned designers such as Tom Dixon and Norwegian creatives, notably through Hydro's design-driven exhibition at Salone del Mobile in Milan. Now based in San Francisco, she continues to bridge industrial innovation with design thinking, helping shape new markets for more sustainable materials, where she believes that architects and designers are key in accelerating greener production and design. With over 30 years of expertise in metals and sustainability, Helen Waykamp is a leading voice in advancing high-performance, low-impact material solutions. She specializes in recycled and low-carbon aluminum, working closely with sectors such as automotive and building and construction to help them meet ambitious sustainability targets. Helen is known for her commitment to innovation, transparency, and certified materials that align with evolving regulations and customer expectations. Her collaborative approach and deep technical insight empower companies to achieve both environmental responsibility and exceptional performance. Remember to please leave your questions for the speakers in the Q&A button found at the bottom of your Zoom window. Without further ado, please welcome Hilda.
Thank you so much, Dan, for the introduction. Good morning from not so sunny California today, and from Helen, good afternoon, I guess, from sitting in Michigan.
Hello.
So let me start sharing my presentation. Can you see my presentation, Dan?
Yes, we can.
Yes, great. So thank you so much for the introduction. We are here today to talk about sustainable and circular materials, and in specific about understanding aluminum and recycling. So the course objectives today is to understand aluminum better from an environmental point of view. We will look at how to better leverage aluminum to actually cut embodied carbon emission and have a specific look at buildings, but of course it applies to all products. And it's not a surprise that in order to do so, a collaborative approach is needed across the entire value chain of material production, and design here, as Dan alluded to in the beginning, is very important. You will perhaps notice that throughout the presentation, we will not talk about green or sustainable materials. As today, I would say that there is hardly no materials that is not leaving some form of footprint behind on nature, people, or climate. But as we will see, some materials are better, or let's say greener than others, and this is what we will look at. We don't expect that you will become a material scientist today, but we hope that you will be able to better understand what questions to ask in order to ensure that the aluminum that you choose for your designs or projects actually contributes in reducing emissions, because that is the aim of this course. So let's look at quickly what we will go through. So the first part, we will give you a general introduction to aluminum and the different routes of production, primary and then recycling, which Helen will dig deeper into. Then we will go on to talk more about environmental considerations of productions, and of course, the opportunities in cutting emissions, which is of great importance here. And then we will round off with a section looking a little bit at how to better specify and select materials that will be able to achieve greener buildings, if you like. So I will turn off my camera now so you can focus on the presentation, and then we will turn it back on when we start with the Q&A section. So let's get started. So aluminum, or aluminium as they say in the part of the world where I'm from. The dictionary definition of aluminum is a silvery white metallic element, light in weight, ductile, malleable, and not readily corroded or tarnished. It is occurring in nature in rock shape, and I would like to add it's used for all sorts of applications. And for many of you, I'm sure, it is also associated with a metal requiring a lot of energy to produce, but with perhaps endless opportunities for designs and shapes. So aluminum is present almost everywhere we go in a vast number of applications. And it's fair to say that our modern society has been built on aluminum, especially this country, I would say. We might not even be conscious about its presence, but we would definitely miss it if it wasn't there. The use of aluminum has many advantages, but production comes with challenges that I've already mentioned and issues that we shall look at more in depth at shortly. But first, let's look at the properties and understand how the metal is made. So aluminum is very strong, but is also lightweight, having 1/3 of the density of steel with similar strengths. Aluminum performs very well in corrosive and harsh environments, being used in many marine and industrial applications. Aluminum is infinitely recyclable. We will come back to that later on. And in addition, aluminum is an excellent conductor of heat. And last but not least, aluminum has fantastic aesthetic properties, especially when anodized. So what's not to like, you might say? However, when you compare aluminum with other materials, you can clearly see that it has a lot of benefits. But as with all material, it comes with both benefits and limitations. Some materials are right for some applications and not for others. As we already mentioned, aluminum has many advantages and has been described as a super materials. But as you can see here, aluminum comes with one big disclaimer. Its biggest challenge is that it requires a lot of energy to produce. There is, however, a silver lining here: recycling of aluminum and use of renewable power sources. Because aluminum is actually a material that is infinitely recyclable. One of the greatest things with aluminum is that it can be endlessly recycled and without losing its properties. Aluminum acts, you can say, as a giant energy bank, which is why recycling held value long before anyone mentioned the word climate change. Financially, as well as environmentally, recycling aluminum makes perfect sense. As you can see here, aluminum actually requires only 5% of the energy compared to primary production when aluminum is recycled. In other words, obvious, but it is a saving of 95% in energy use when you recycle old aluminum. Few materials have such a big energy saving when recycling as aluminum. If handled well, we could support a lot of more of our metal needs if we had better recycling of the metal. This requires work throughout the value chain, from design for recycling to collection, sorting, and recycling. And Helen will get back to the challenges and opportunities here. But first, let me look at the two different ways of how aluminum can be produced. As we have already alluded to, there are two processes of producing aluminum: the primary and the secondary production routes, or recycling, if you like. Let's first look at the primary route before Helen will dig deeper into the scrap pile to understand the challenges and opportunities in recycling aluminum. Primary production. As you can see here, you can see an overview of the start of the aluminum value chain. Aluminum is, sorry, a bit of glitch there. Aluminum is found in the Earth's crust, and bauxite is a red rock found mainly in tropical and subtropical regions. My apologies, I have some hiccups and so aluminum is the third most common element in the Earth's crust. But in order to extract it, you have to go through a complex process first. You do not find aluminum in the soil in its pure form. Bauxite is typically extracted through open pit mining, as you saw in the first image, which involves removing the topsoil and vegetation to access the ore beneath. With, as you can imagine, many issues relating to people and nature that needs to be considered and dealt with. How reforestation and biodiversity is handled in mining operation is a key question to always ask when talking about primary aluminum. Today, you should be able to get aluminum produced in a responsible way, and we will look at this when we look at certifications to better understand what questions to ask and certification to look for in terms of responsible production. So bauxite resources are estimated to be between 55 billion and 75 billion tons. The majority of the bauxite used for aluminum production in the US is imported from countries like Brazil, Guinea, and Australia. And you can see the major bauxite producing countries here. As you can see, some of these regions are largely composed of developing or emerging economies, and the sensitivity around bauxite stems from environmental, social, and geopolitical concern tied to resource extractions in these places, and needs always to be taken into consideration when selecting primary aluminum. After the bauxite is extracted and mined, it is processed, like you can see here, and crushed into smaller bits and transported for refining. Bauxite ore is then dissolved into something called sodium hydroxide, or lye, at a very high temperature and pressure. Then the alumina and bauxite ores are separated by washing out the waste, which is red mud or sands, from the alumina. Finally, hydrated alumina is crystallized and calcinated, which means dried in a furnace, to produce what is called solid alumina. Alumina is then this white, almost table salt-like material that is properly called aluminum oxide. And any idea how much alumina is required to produce 1 ton of aluminum? Well, the answer is approximately 2 tons, so twice as much. So as you can tell, so far a quite complicated process. Then finally, alumina is delivered to a smelting operation that can be anywhere in the world, such as this one. Here you can see aluminum pot lines, which is a series of large electrolytic cells in a smelter that produce the actual aluminum. The cells are electrically connected in series, forming a cell line. This process requires a lot of energy, which is of course very problematic if the production is based using coal, oil, or even gas. And as you can see from this graph, smelting, so this part, is the most significant source of aluminum's emissions, and this is why this part of the process needs to be decarbonized the most. So let me try to sum up. To turn this red rock of bauxite into hard aluminum billets, bauxite in mined. The mined bauxite is crushed and ground into fine powder. The alumina powder is transported to primary sites where a very energy-intensive process turns it into liquid aluminum. Small quantities of other materials, such as copper and magnesium, are then added to achieve desired alloy grades before being casted into the desired product groups. Helen will explain more about alloys later when she talks about recycling. And this whole process, as you have understood, requires a lot of energy. Finally, the aluminum is produced into various products like extrusion billets, sheet ingots, or other aluminum products that again can be turned into sheets, extrusions, precision tubing that can be used in end products like this beautiful extruded bench from the designer Lars Beller, or of course, whatever product you need to produce your end product for. What I'd like for you to remember from this first part of the presentation is that primary aluminum is energy intensive in the making, but the source of energy used will heavily impact the footprint of the metal. Between aluminum production with hydropower and coal power, we're talking about a factor of up to 5 to 6 times as high emissions. With recycling, you can cut emissions even more. This is why today the fastest way to cut emissions from aluminum sector is to increase recycling and the use of recycled products. I will hand over to Helen, who will walk us through what you need to know about recycling of aluminum. Over to you, Helen.
Thank you, Hilda. So secondary or recycled aluminum is another processing route. So I'm going to spend a few minutes describing this process and some production challenges and opportunities. But before I do that, I do want to emphasize some of the things that Hilda said. For primary aluminum, it takes 4 kilograms of bauxite ore, the red dirt, to produce 2 kilograms of alumina, the white powder. And then these 2 kilograms of alumina are needed to produce a single kilogram of primary aluminum. And then again, the energy required to recycle 1 kilogram of aluminum is only 5% of the energy that was needed to produce the primary aluminum. So this makes a great case for recycling of aluminum. And I'll just describe some of the processes. So what's involved in secondary aluminum production, and how do we incorporate recycled material to give it a second life? Well, in order to produce new aluminum products from recycled scrap, the metal needs to be recovered and then sorted with advanced technology to ensure the purity and alloy type before it can be melted down to a liquid state and then added to a casting process. So what do I mean by alloy type? Aluminum alloys are broken down by alloy groups or alloy series from 1000 to 8000 series. The first number in the series tells us the main alloying additions. So for 3000 alloys that are used to produce beverage can aluminum sheet, manganese is the main alloying addition. And then for 6000, which is typically used for building and constructions, magnesium and silicon are the main alloying additions. And this is important because when we recycle, we need to essentially be within the same alloy series. So in general, we don't typically recycle beverage cans back to produce 6000 series aluminum because the alloying additions are different. Then within the alloy series, you have different grades of aluminum based on how much of the alloying additions are added. So for 6000 series, again, that are typically used for building and construction, you have alloy 6063 with little magnesium and silicon added, resulting in lower strength, as compared to an alloy like 6061 with more mag and silicon that gives the higher mechanical properties. So in recycling, these alloy systems and alloy grades need to be sorted in order to get the full value of the scrap. So it's important to understand the 2 types of scrap pools that we can use for recycling. The industrial process or pre-consumer scrap has never been a product. And this is a great source for recycling because it essentially comes back to the cast house sorted. So when you look at this picture, each bundle of the profiles is essentially the alloy grade because that's how it came back from the industry where it came from. So it's easy for the cast house to then recycle it. They just keep that bundle together and load it into the alloy that was produced. But post-consumer scrap or end-of-life scrap has already been through a life cycle. So there's no disagreement in the industry that this has a zero carbon footprint. But you can see from this pile, it's a bit of a mess. It's not sorted and it contains paint or coatings that need to be removed. Both of the scrap are important for recycling, but recycling post-consumer scrap prevents this metal from going into a landfill. It reduces the need for virgin or primary aluminum, and it cuts emissions significantly. So I'll dig a little deeper here into these types of scrap. Pre-consumer scrap or processed scrap. This refers to waste generated during manufacturing, such as trimmings or offcuts or rejected parts. And as I mentioned, this scrap is often clean, it's sorted, and it's easy to recycle. While this is efficient and valuable, it's not new. The industry has been doing this for decades. So pre-consumer scrap doesn't really represent a net gain in circularity because it's never left the industrial system. Now, if we look at post-consumer scrap, this is aluminum that, again, has completed its life cycle from buildings, cars, electronics. But again, it's often mixed, contaminated, and hard to collect and sort. But it does represent true circularity, a true circularity opportunity. Processed scrap has been recycled for many, many years, and it's a great source of recycling. But really, we should be looking to minimize waste in production, and that should be the priority. The real opportunity to cut emissions from aluminum production lies in making use of post-consumer scrap and saving this from ending up in the landfills. So what does it take to recycle post-consumer scrap? Well, first, it requires advanced sorting technologies that I'm going to describe here. But it also requires us as metallurgists, or me as a metallurgist, to design recycle-friendly alloys. It requires processes to remove paints and coatings. But it also requires a pull from the market. I'm going to describe the complexity of sorting post-consumer scrap, but a pull from the market would really incentivize development to make this process more efficient. So this is an example of an automobile going through the shredding and sorting process. Segregating the material has historically been very challenging, but I'll describe advancements in technology that allow us to sort at a production scale. Each one of the process steps that I'll describe can and do happen at multiple times during the process to ensure that all the non-aluminum materials are removed. So after the car is shredded, it first goes through magnetic separation to remove the ferrous material. Then eddy current separates out the non-ferrous materials like aluminum, copper, and brass, leaving things like plastics, plastic bumpers that would end up as an off-fall. Then X-ray technology is used to separate mixed aluminum alloys from heavy metals such as the copper and brass. So at this point, we have a pile of mostly aluminum, but it is the mixed alloys. It could be 7,000 and 6,000 series alloys together. There are new technologies being developed to allow us to sort out these individual alloys. And one example is this LIBS system. This is laser-induced breakdown spectroscopy. And this sorts out individual alloys like 6063, for example, so that we can melt that back into a 6063 cast. But even with the best sorting technology, some trace elements do remain from things like coatings or adhesives or other metals that were bound to the shredded metal. So it's important to account for this when we have specifications for these materials. So at this point, I've explained how we can take end-of-life scrap through the advanced sorting process to create recycled material that goes back into high-quality consumer products like this window frame. But here's the unfortunate reality. The US currently sends more aluminum to landfills annually than it produces as new metal. And while exporting large quantities of high-quality aluminum scrap. In 2023 alone, approximately 2 million tons of aluminum scrap were exported overseas, and if all the aluminum would have been saved from the landfills, it could have provided enough material to produce 11 million cars annually. Right now, American manufacturers are striving to strengthen domestic production and decarbonize their footprint. So collecting and recycling this end-of-life scrap would really fill the aluminum supply gap that we're currently filling with foreign imports. So now I'll let Hilda take this back and look at some of the environmental considerations.
Thanks, Helen. Okay, there's a lot to take in, and I will try to repeat some of it, but hopefully this gave you a background of both the primary and the secondary route of production. But all production comes with environmental challenges, both the secondary and the primary. The good news is that there has been done a lot of work by companies to cut emissions from production the last year. This is also relevant for aluminum producers, so steel and cement as well, for that matter. And combined with new regulations that incentivize use of materials with lower emission and forward-leaning companies setting sustainability targets for their products and operation, we're actually starting to see some effects in emission reduction in parts of the world, which is important, which is of course more important than ever as consumption is growing. And you can see this in this graph here. The world increasingly demand more materials, and this is the case for aluminum as well. Demand is growing, driven, partially by the need for materials to a world that is growing out of poverty. That is a good thing. Houses are built, roads are made. The green transition also, ironically, I could say, also requires more materials to build, the wind turbines and our new electrical cars that requires metal. The good news is, as you can see here, I recently learned this, that emission intensity of aluminum production has actually recently been moderately declining by about 1.7% year on average since 2017, driven largely by declining energy use of alumina production. However, to accelerate reduction in emissions, we need to increase a further reduction of at least 4% CO2 emissions per year on average from this sector in order to reach the net zero emission targets for this sector. So how can we go about to help cutting those emissions when the world is actually demanding more materials? So, as I'm sure many of you know, and especially the architectural community has always known, that aluminum can be a so-called environmental bad guy. And that is right on a global scale. Aluminum is considered, or not only considered, is a material with a high footprint. As you can see from this chart, the so-called global carbon footprint of aluminum can be comparatively high or extremely high to other types of raw materials. However, the footprint of aluminum, due to its high use of energy, depends a lot on the energy source used to produce it. So, since all aluminum is not creatively equal, we need to look at the source and the production of the material to really understand the individual impact and select accordingly. Looking at global numbers, or global average numbers for materials doesn't really allow for a good comparison and doesn't make sense. So if we all select aluminum based on the lowest CO2 use, we could accelerate cuts. So let's dig deeper into this. It really matters where and how aluminum is produced. Globally, coal power plants still account for a large proportion of the world's energy mix used to produce primary aluminum. The fact is that the global average of aluminum has a CO2 footprint of around 16 kilograms per kilo aluminum produced. So per aluminum produced, just think about it, 16 times as much as CO2 is actually created. However, some aluminum smelters are fully powered from water and wind. Norway and Canada are two examples. This means that there is already today aluminum on the market with guaranteed less than 4 kilograms CO2 per kilogram aluminum produced, which is 4 to 5 times less than the global average. And if you compare it with coal-based power plants, it is actually 6 times less than if produced, between coal and hydropower. So it does matter where aluminum comes from when looking at the total CO2 footprint and the environment input of the product. And in addition, to eliminate the hard-to-abate emissions from the process of production, there are essential now 3 paths undertaken by the industry to reduce carbon footprint and ultimately achieve zero emissions aluminum. So the 3 paths to zero. The first path is obtained with development of brand new technology utilized in the smelting process. Remember, that is the process that really needs to be decarbonized. There are a few of these projects undertaken by the industry today. One is what is called the inert anode smelting that emits oxygen instead of CO2, called the HAL0 process. And the other one converts alumina to aluminum chloride before the electrolysis, then emits oxygen and not CO2, and it's called the lysis process. Companies have been working on these types of zero CO2 off-gas emission smelting technology in a lab scale for several years, and have recently put them into full-scale production, but on a limited basis. So we're still far from commercial volumes here, and we don't know exactly how this will work. So this is a kind of we hope that this will work scenario. The second part to zero production in the aluminum industry and in many other hard-to-abate sectors is the carbon capture and storage, or CCS technology, if you like. This road to zero is important to secure the value of existing primary aluminum smelters and to take out the rest of the CO2 from the production. For these assets, carbon capture and storage solutions are being developed and can take out the last emissions from the process. However, the third part to zero is recycling, and this is actually the only one that is available at scale today. Recycling aluminum is certainly nothing new, and it's been done for decades. What is new and continues to progress is what Helen has talked about, is the ability of recyclers to utilize more and more types of scraps of aluminum, particularly post-consumer scrap, to make high-quality aluminum billets comparable to primary aluminum. So, as I'm sure you know, there is a tremendous amount of innovation happening in the search for new and more sustainable materials, which is of course good. But this is hard work, and many emerging materials face challenges with scalability, durability, and cost. Meanwhile, metals like aluminum and steel have been with us for decades. We know them, we trust them. They're strong, lightweight, versatile, and endlessly recyclable. So when we find ways to produce these materials, as we've seen here, with low or even zero emissions, whether through hydropower, green hydrogen, or recycled inputs, it's not hard to argue that they become super materials. Looking at this checklist for material selection for a building, it is easy to see that a low-carbon aluminum would fit the bill. This is why it's important to be able to understand how to select aluminum that is produced in a way that will actually contribute in cutting emission globally. But before I go into this and how to be able to differentiate greener aluminum, I have to mention that sustainability in the aluminum industry is of course more than CO2. As you could see from the first part of the presentation, looking at the complex process of producing primary aluminum, in order to understand the total impact of the industry, it is important to look at the impact of the entire value chain on both nature, people, as well as climate. This is also the case for recycled metal. Companies' commitment to biodiversity, waste management, and reducing emissions in operations are equally important when selecting materials. Not to forget the societal development and how companies who operate and treat people that are in some ways touched by their production. Today, we will, however, focus on the climate aspects, but always keep these 3 pillars of sustainability in mind when selecting materials. So let's look at a few important ways in order to understand carbon emissions from aluminum production. It is important to take into account and understand what is called scopes. In order to compare apples and apples, the Greenhouse Gas Protocol, or the so-called GHG, is an international recognized method for calculating and reporting greenhouse gas for companies and organizations that enables to compare the emissions along the whole value chain. Reporting in accordance with the GHG protocol takes place in 3 different scopes and is referred to as scopes 1, 2, and 3. Let's look at one of them at a time. So scope 1 includes what is so-called direct emissions of greenhouse gases within your company's own operations. The main source, for example, of scope 1 emission for an aluminum company like the one I work for are anode consumption during the electrolysis process and the use of fossil fuels. For a construction company, on the other hand, one typical scope 1 emission would be diesel, petrol, or gas used in construction machinery, generators, or vehicles. Scope 2, however, includes what is called indirect emissions of greenhouse gases from purchased electricity, heating, cooling, and steam, for example. The main source of scope 2 emissions for my company is the consumption of electricity purchased through the grid. For a construction company, it will be, for example, indirect emissions from power drawn from the grid for lighting, temporary site offices, etc. The last scope 3 includes the so-called indirect emissions of greenhouse gases that occur elsewhere in the value chain. For a construction firm, it will be emissions from the production of cement, steel, aluminum, glass, insulation, and other materials. It is important for materials such as aluminum that all scopes are included in the carbon footprint calculations to understand the metal's actual environmental footprint from the mining until the very final delivery at the construction site. And it's important to note that this is not always the case, that all scopes are accounted for when emissions are reported in terms of the materials. The second element when it comes to aluminum and calculating carbon footprint is that it's not always a one-size-fits-all. There are actually in the industry today 2 main methods for calculating the footprint, in addition to the scopes that I mentioned, that are commonly adopted across the manufacturing industry. And a method chosen, we will look at this later, can have significant impacts on the carbon footprint of materials when especially recycled content is involved. Let's look at the 2 ones. The first method is called the so-called avoided burden method, or an even more complex name, the co-product allocation method. This method follows the material and acknowledges that all production and material emissions should be accounted for. I will explain this more when we look at recycled method. The second, the so-called cutoff method, is a default method for many aluminum and steel producers, and it follows the products and treats pre-consumer scrap very differently than in the first method. I would say that in Europe, probably the avoided burden is used more, and in the US, the cutoff method is used more. It doesn't distinguish between the pre and post-consumer scrap. That doesn't always have to be problematic, but it can be. I will come with an example of this. So here you can see an overview of the different calculation methods in practice. As I will try to show you with using a pointer here. So as you can see, When it comes to the primary metal, the footprint within these two calculation methods are the same. However, when it comes to the use of pre- and post-consumer scrap, you will see that the calculation methods would differ very dramatically when there's a lot of post-consumer or old aluminum used. So you can see that the red columns shows the number using the cutoff method, where you can see the primary metal comes out with the same footprint. Until there is an agreement in the industry, the most important part for you to understand is that there are two methods here, and that you need to ask which method is used in order to compare apple with apples. Another important takeaway, of course, from this slide on a more optimistic note is that aluminum today can be produced with a very low footprint. If you use 100% post-consumer aluminum scrap, as you can see here to the far left, the metal can actually be produced with hardly any footprint at all. This product is available today, but limited due to the access to post-consumer scrap. But products here with around 75 to 80% post-consumer scrap is available in commercial volumes in North America. And of course, you also have the opportunity to have a recycled product that has a mix of also primary produced with hydropower in that can reduce the emissions in production. So let's look at how we can drive sustainability through the use of more aluminum scrap. As we have seen, there are many benefits to recycled aluminum. Reduction of CO2 footprint without losing strength or quality, reducing waste and promoting circularity, creating a strong and more local supply chains for this metal are some of them. We often get questions if this metal is of the same quality as primary aluminum, and the answer is yes. If the metal is sorted right, as Helen discussed, it can perform in the exactly same way. Current data shows that approximately 30 million tons of aluminum is recycled annually on a global scale, with an efficiency rate of 76%. This means that approximately 9.47 million tons of scrap, a lot of numbers here, is lost or unaccounted for. To fill this gap using primary aluminum, it would mean approximately 141 million tons of carbon would be produced. And of course, by selecting recycled metal, this can be avoided. So by doing so, you could, for example, save primary metal that will be enough to produce 47 million passenger vehicles, or perhaps 6 million new homes. So it's just to put it at scale. So let's look at how this can make a difference in practice. Embodied carbon in a building refers to the greenhouse gas emissions from producing, transporting, and assembling building materials along the whole value chain, along all the scopes as we have discussed. For a typical office building, the embodied carbon range from 500 to 800 kilos CO2 per square meters, depending on design, materials, and location. This means 100,000 square meters, or 10,000 square meters, or 107,000 square feet office would emit 5,000 to 8,000 metric tons of CO2 even before it's occupied. The majority of embedded CO2 comes largely from materials like concrete, steel, and aluminum. By choosing low-carbon aluminum for facade, windows, and cladding, we can significantly reduce the building's total emissions. As you can see here, that aluminum is probably a material that can be present in all these parts of a building. And if we dive a bit deeper into it and look at a specific component like a window, the aluminum part represents 65% of emissions of CO2 emissions of this window. And in addition, the recycling potential is high, as well as the durability and maintenance costs are low along the lifespan of the building. All facts that, of course, should be taken into account in the material selection. And if you further look at potential savings, I thought it was interesting to add these examples from the automotive industry. This is the case of a Volvo car, compared the savings if the car was made out of 100% secondary materials. You would reduce CO2 footprint with 85%. That is said today, that is not possible to produce a car with 100% recycled metal, but it just, or recycled materials, but it just shows the potential when that is possible. And here, of course, also you can see that the metal part and the PVC part of the equation represent a very large part of the footprint of the car, which is, of course, the same in the building. So let's round off and look at how we can accelerate change. There are today, thankfully, certifications and standards that can be used to guide you in order to ensure a greener selection of materials. And we try to give you a quick overview here. For aluminum, the following certification can be good to be aware of. And as you can see, different certifications depending on where you are in the value chain. Let's start with the raw material extraction. ICMM, the International Council on Mining and Metal, is a global leadership organization that brings together mining and metal companies committed to responsible and sustainable practices. If you see a company is a member here, you know that it has been through a rigorous admission process to commit to sustainability targets, and should be a good sign that the metal is produced in a responsible way. Then it is ASI certification, the Aluminum Stewardship Initiative. This is a certification that is relevant along the entire value chain of production. The main difference, there are two main certificates that you should be aware of: the ASI Performance Standard and the Chain of Custody. The latter is probably the hardest to get, and it guarantees that the metal is can be traced along the entire value chain of production, and is segregated and treated along the principle of sustainable production from a people, society, climate, and nature point of view. So ASI certification is something you should always ask for. Then it is the environmental product declarations, or EPDs. You can ask for EPDs for all aluminium products, and there are many types of EPDs, and they are all standardized, third-party verified, and should be able to communicate the environmental impact of a product from raw material extraction to disposals. And these EPDs, again, to use another acronym, is based on a life cycle assessment. Then you have the ISO standards that you get for all sorts of products. The one that is relevant for the recycled aluminum industry is the ISO 14021 that defines recycled content. So that's something to look into. And last but not least, you can also ask the individual aluminum companies for individual certification on a batch-by-batch basis. This is probably the best way to ensure responsible production, as you know that the aluminum you get is not an average, but the CO2 number reflects the actual physical footprint created when creating that material. So what can you do? We know that sustainability starts at the drawing board. So specifying the right material is, of course, of essence. First of all, we would encourage you to specify aluminum products with high post-consumer content and ask for certification covering all scopes of productions. Do not specify recycled content without getting the information about the pre- and post-consumer scrap percentage and the CO2 emissions and method used in calculating. Ask manufacturers to disclose the scrap origin, prioritize in this market US or local post-consumer sources. Educate clients on the long-term environmental and economic benefits of recycled aluminum and the importance of selecting materials that actually reduce waste and carbon footprint. Take part in trainings, yeah, well done, to educate and learn more. Design for disassembly, learn more about how production can be adopted to design for recycling. Specify recycle-friendly alloys, and reach out to manufacturers and industry bodies to learn more and get batch-by-batch information to specify better. So we have added at last some useful resources where you hopefully can learn more about this. And I hope you learn that despite its reputation, aluminum can be a future-proof material for the buildings of our future. By specifying responsibly sourced low-carbon aluminum, you're not just meeting standards, you're setting them. So I think with this, we can open up for questions and discussions.
Great. Thank you so much. I'm going to begin reading some questions from the Q&A. Question from Daniel. Where are the primary aluminum processing sites in the world? Where are the primary aluminum and where are the primary aluminum recycling processes sites?
Okay, I can answer the first, and then Helen, you can talk about recycling. So there are primary production all over the world, including in the US. Norway and Canada are known for countries where you have primary production using energy input from hydropower. So that's probably where you have the lowest emissions. But you also have primary aluminum production in China and the Middle East. Helen?
Oops, sorry. Yeah, and then recycling, you can have it globally. As long as there's recycled material available, you can have recycling centers. So like our company, we have 3 recycling centers here in North America.
Great. Another question. What is the cost difference between primary and secondary aluminum? And what is the cost difference between conventional and zero carbon aluminum?
It's a very good question. And of course, it depends the market. Here in the US, we have the Northwestern Premium, but the general question is that the cost between a primary and aluminum and recycled aluminum metal has been quite similar. Recently, with the advanced sorting technologies that had enabled companies to sort and dig deeper, if you like, into the scrap pile and sort more aluminum, aluminum with a high percentage of post-consumer content is slightly more expensive than aluminum bought primary aluminum. However, primary aluminum produced with hydropower or renewable sources tend also to be slightly more expensive than the grayer options, if you like. But the costs are not significantly higher.
Great. What are special post-consumer problems for recycling aluminum curtain walls, such as paint versus anodized and sealants?
Well, I think I touched on it. We do have to have a way to remove those and remove it in a sustainable way. So we have delacquering systems available where we capture the off gas and make sure that we're doing things in a sustainable way. But you have to have a delacquering system, otherwise those contaminants can end up in the metal.
Okay. Um,
If I can add, it's a very good question because it comes back to design for recycling. It is also it is important to understand, of course, buildings, have a tendency to exist for, 50 to 100 years. Of course, it takes time before the metal gets returned, but eventually when a building is being demolished, how can you make sure that the building is designed for disassembly and for recycling in the most sustainable way, also when it comes to surface treatment?
There's a question from Greg. Will the tariffs have any effect on the cost of aluminum?
Yeah.
Yeah, I can answer that. Yeah, I think we all know that the tariffs, will have an effect on imports, and this is, of course, why the case for recycling in North America or in the U.S. now is perhaps also an economic one, or perhaps more so a case for a case where you can secure your supply chain in a better way. So yeah, I think that's how I will answer that. But yeah, tariffs will often have effect on pricing.
Great. We have time for either one or two more questions. I'm going to read one from Catherine. Catherine has heard that recycled plastics are typically not as strong as virgin plastics due to the fiber structure becoming more dense and losing elasticity. Is this true for recycled aluminum products? And is the structural integrity of recycled aluminum products different than virgin aluminum products?
Well, I think there's a couple things. As long as you have a good sorting process, like we talked about, then you maintain the integrity of the material. But there are some products where it's difficult to use 100% recycled content, like very strict aerospace components, maybe used on the upper wing structure where they have to have very, very low iron content. That would be a case where you would have more primary or primary aluminum. But again, if you have and there's some like anodizing qualities where you might need to have more primary added, but not full primary aluminum. So I think it depends on what the product is.
Great. We have time for one more question from Jenna. What are your views on extended producer responsibility for aluminum products and associated fees?
Well, that's an interesting question. I cannot say necessarily what is as our company's views, but I can say that from a personal point of view, in order to increase circularity, we need to ensure that the products can be collected and sorted and then recycled accordingly. So the incentives and the regulations that will enable us to collect more, in our case, aluminum, I would support. I don't know that initiatives in detail, so I cannot comment on it in specific, but it is for sure the case that we need, whether if it's regulations or if it is designed for recycling, or probably a combination of many things, in order to make sure that we can increase the recycling rates of products. And especially in the US, the numbers are dramatically much lower than those in Europe, and it shouldn't be. So there's a great potential here.
Great. Well, thank you both. I'm going to give some closing words to wrap things up. Thank you all so much for attending the live webinar, Sustainable and Circular Materials, Understanding Aluminum Recycling, a CE Strong webinar series powered by the Architects newspaper. This presentation was sponsored by Hydro. This webinar is recorded and can be easily replayed using the same registration link. Please allow 7 business days to process certificates of participation and AIA credit reporting for this presentation. A big thank you again to our presenters, Hilda Kellevig and Helen Waykamp, and to Hydro for sponsoring this webinar. We hope to see you all again at a future event. Have a great day.